Good morning, fellow programmers. You have reached part 6 in a series of tutorials about Chromia and Rell. I'm assuming that you are a developer from the normal world attempting to enter the golden lands of crypto. With Chromia, the step is very small, but there are some things to consider. By creating the lobby of this game, we will learn more. A lobby is a place where players can find each other and create new games. In Goblin Chess, the player can choose if she wants to play fast or slow and classic or chaotic. So we need a game type for that. Only two players who chose the same game type will be matched. The idea is that when a player enters the lobby, a lobby entity will be created. In the normal world, if a player gets tired and closes the app, the connection will die and we can remove the player from the lobby on this event. But on Chromia, we don't really have a session. Every transaction must be seen as a unit. Either the data is written to an entity or it is forgotten as soon as the transaction is finished. So, while it's trivial for us to detect when a player enters the lobby, we have to detect when the player exits. We can solve this by collecting heartbeats from the client and update the lobby with the last timestamp. Cursor created an entity as I told it, but perhaps it's easier to use an enum since I only have 4 combinations. Players should be able to think in total 5 or 10 minutes and play classic or chaotic mode. Remember that even though the lobby entity only saves the last heartbeat, all heartbeats are forever saved in the blockchain, so we have to be smart about not sending them too frequently. By making the player reference unique, Cursor only allows 1 lobby entry per player. I changed this to allow a player to wait for all game types in parallel. I copy the game and lobby entities and open the operations Rell file. I press Ctrl L to open the chat and describe what I want. I want to create a query where we send the player signer and the game type. We look for another player via the lobby entity of the same game type as we provided and where the other player's ELO rating is as close to our own as possible. If we don't find a player within 200 ELO points, we return nothing. The idea here is that Cursor should figure out it has to join the lobby and the player entity to fetch the one row that best fulfills my requirements. In the documentation we find that Rell allows one-letter aliases when we use a multi-entity query. We declare the entity alias like a normal variable, with the variable name u, then colon, then the type user. On the same page, we see that the limit keyword works just like in SQL. When you use sort in Rell, it looks like this. Now this is the generated query. First, when the client sends an enum, it's best to send a primitive type like integer or text. Cursor picked integer, but I prefer text. To turn the text into an enum, in Rell we use the value method on the enum type. Cursor is confused about how to join tables. It's mixing traditional SQL and Rell, so we have to sort it out. Even if Cursor is weak with the Rell syntax, it's still capable when it comes to logic. Cursor here remembers to check that we never play against ourselves, an easy thing to miss. As we saw in the docs, Rell does sorting differently. In Rell we simply put the flag @sort before the return value we want to sort. It's very common that we store the result of a select in a variable. In this case, the variable might be null, but if it's not, we extract the found pub key and return it. It's not required, but it's good practice to declare the return type of a query. In this case, we must put a question mark after the type to signal that it might be null. One thing Rell does differently is that when we join on the primary key, we usually never write out the primary key. Since all entities have row ID as primary key, this is implicit. For example, when we prevent playing against ourselves, the idiomatic way would be comparing the entities on primary key instead, like this. Note that this syntax bridges a conceptual gap. P is of the type player, requesting player is of the type player. We are comparing two instances. I forgot one thing. I must check that the heartbeat in the lobby isn't too old. Here we require the client to send the current time. The reason is that blockchains are deterministic, so time and randomness work a bit differently. We need to set the heartbeat somehow, so we write an operation for when the player enters the lobby. First, we reuse the code from episode 4, where we fetch the pub key from the transaction. We use the pub key to fetch the player. Note that we use the @ without any question mark, meaning that there must exist exactly one row or the operation explodes. We get the enum from the text type, just like in the query. Now we look in the lobby for any row matching the player and the player game type. If we don't find anything, we must create the entity. But if we already have the row, we should update the heartbeat. In the docs we see that when we update, we can either use the @ syntax with question mark and star to determine how many rows we expect to find, or if we have the entity in a variable, we can update it directly. In our case, we have the existing lobby, so we can set the last heartbeat directly. We use OP context from episode 4 to fetch the last block time, which is a deterministic timestamp that's written to the block and never changes. Okay, that's enough for now. See you in episode 7.